volume zero conversion. B x equal to 1 minus B x equal to 0 by B x equal to 0. Let me see whether the terminology is same or not. Yes, the terminology is correct only. Yeah, what is the name? Yeah, the name is also correct. Because different authors have a different way of interpretation. Okay, so what is the fractional change in the volume? Whenever any volume is varying, whenever any volume is varying. So till last class, we have learned the concepts of constant volume, wherein your V is constant. That's why you took V inside the derivative part, dCA by dV. That's why your minus RA 1 by V dNA by dt will become dCA by dt, because volume has changed inside. But now volume is varying. That means your volume with which you started the reaction will not be the same after some time or after completion of the reaction. So your initial volume, final volumes are going to be changed. That means if I start any reaction with, let us say, volume V0, your volume will be subsequently changed to V after the reaction. So you cannot use V for all the time. You may start with V0, but it will definitely change to V. Now, what is this change of volume, or what is the fractional change in the volume, can be represented with epsilon A, which is equal to volume at complete conversion minus volume at zero conversion by volume at zero conversion. That means during the course of reaction, what is the change in the volume to the what is the initial volume. So volume at 100% conversion, that is x equal to 1, that is xa equal to 1, xa equal to 0, xa equal to 0. Fine. That means in all our expressions, wherever V comes, V will be changed. How it will be changed? V equal to V0 into 1 plus epsilon A xa. Now your final volume will be initial volume times 1 plus epsilon A etc. Fine. Let us say if it is a liquid phase reaction. Let us say if it is a liquid phase reaction. Liquid phase reaction means there is no change in the volume. So that means your epsilon A will become 0. So this fraction will become 0. That means V0. V equal to V0 means whatever initial volume you take, final volume. That means there is no change in volume. So constant volume case. We have already done constant volume or constant density varying pressure systems till last class. We done now? Constant volume also called constant density, also called varying pressure. So wherein this term will become 0. So if term will become 0, V0 means V. So that means initial volume, final volume becomes initial volume. That means there is no change. Where we started initial volume, we are ended with the same final volume as V0. That is for the constant volume case. Now we are studying varying volume case. Now your volume will change. Your volume will change with initial volume multiplied with this term. V is equal to V0 into 1 plus epsilon A xn. Now that epsilon A is called fractional change in the volume. How we define? Volume at 100% conversion minus volume at 0% conversion. Okay. Let's look at the epsilon A calculation for a simple reaction. Maybe I can take an example as A gives us 4R. Let us say for this reaction I want to calculate epsilon A. Conversion. That means what? If the reaction is completely converted, what is my final volume minus volume at 0% conversion, volume at 0% conversion. So what is volume at 100% conversion? If the reaction is completely given time to completely go on, 1 mole of A is giving 4 moles of R. 4 moles of R of the complete conversion. If I give time, completely converted means 4 moles are getting. That means 4 times the volume has increased. Minus 0% conversion. That means nothing is converting. What fraction of moles is there? They will still remain as it is only. They are not at all converting. How many moles are given? A mole is there. It will be remain as it is only. It won't convert anything. That's called 0% conversion. By 0% conversion. Is it clear? For any reaction systems, we can able to calculate epsilon A. But we should be very careful in calculating epsilon A when you have inerts in the system. Because in gas phase reactions, more often inerts will add to your system. Inerts will come into the system. What is inerts? Inerts means the substances which come along with the reactants, but they won't interfere with the reactant system. They will as it is come. So that means what? Your components are not pure. Because if they are impure, only some inerts are coming. If they are pure, there won't be any inerts. If the components of the system are inerts, then only it is not pure. So whenever inerts comes into picture, we should be very careful in calculating the epsilon A. We do one problem of inerts calculation. Maybe I can take an example here. Yes. Take the case of same A to 4R. Say in this case, let us say for the same this case, if we have inerts, let us take the same case. A gives 4R, and in the problem given 50% only A and remaining 50% inerts. So whenever inerts given in the problem, we should be more careful. We should divide a line. We write before R, we can say 100% completion, 0% completion. Better you put like this and write in terms of moles only. Volume in terms of moles. See, if it is 100% completed, how many moles has to come? 4 moles has to come. But 50% inerts are there. 50%, that means 0.5 moles will be inerts. Remaining 0.5 only there. Remaining 0.5, 4 times it will. So that means how many moles? How many moles? 2 moles. It gives rise for Conversion. Zero means means will be as it is only, they won't convert at all. 50% and the fraction of in this case which is 2.5, in this case which is 1. So what is our extra case? V at x equal to 1 minus V at x equal to 0, V at x equal to 0. Or in terms of volume and contact force. At 100% condition we have 3.4. At 0% condition we have 1. Reaction చెప్ అడుగు reaction ఖచ్చితంగా ఉంటాయి కాబట్టి ఆ పాయింట్స్ ఆల్మోస్ట్ అలాగే వచ్చేసింది. See, you have started with 50% of A and 50% of innards. What I told the meaning of innards? They just come, they just go. That indicates your fractions are impure. That is the meaning of innards. Innards లేదనుకోండి ప్యూర్ కాంపోనెంట్ వచ్చినట్లు. మనం ఆల్రెడీ ప్యూర్ కాంపోనెంట్ ప్రాబ్లం కూడా చేసాం. ప్యూర్ కాంపోనెంట్ అంటే ఏ తీసుకుంటే ఏ ఒక్కటే ఉంటది. ఇప్పుడు ఏ కాకుండా చూడండి, ఏ కాకుండా వేరే ఇన్నర్స్ వచ్చింది. ఆ ఇన్నర్స్ ఏమవచ్చు, నైట్రోజన్ అవ్వచ్చు, ఆక్సిజన్ అవ్వచ్చు, కార్బన్ డైఆక్సైడ్ అవ్వచ్చు. నాకు కావాల్సిన కాంపోనెంట్ గేసెస్ కాంపోనెంట్ గురించి మాట్లాడుతున్నాం, ఎందుకంటే వేరియబుల్ వాల్యూమ్ కేస్. గేసెస్ కాంపోనెంట్స్ లో నైట్రోజన్ కూడా ఒక గ్యాసే కదా. నీ కంటి కనబడకుండా మనం పీల్చేది కూడా ఆక్సిజన్ కూడా నైట్రోజన్ వెళ్ళిపోతుంది మన బాడీలోకి. వీఆర్ నాట్ టేకింగ్ ప్యూర్ ఆక్సిజన్. వాట్ వీఆర్ ఇన్హేలింగ్ ఈజ్ ఆక్సిజన్ అలాంగ్ విత్ సమ్ ఫ్రాక్షన్స్ ఆఫ్ నైట్రోజన్, సమ్ ఫ్రాక్షన్స్ ఆఫ్ కార్బన్ డైఆక్సైడ్ అన్ని పోతున్నాయి. అండ్ ఆల్ ఐ కెన్ సే ఆర్ ఇన్నర్స్ ఇన్ మై కేస్. ఎందుకు ఇన్నర్స్ అని చెప్తున్నాను? నాకు కావాల్సింది ఏంటి? ఓన్లీ ఆక్సిజన్. దట్ ఈస్ ప్యూర్, బట్ ఐఎమ్ నాట్ ఇన్హేలింగ్ ప్యూర్. ఎప్పుడు మనం ప్యూర్ ఆక్సిజన్ తీసుకుంటాము? మనం పేషెంట్ అయితేనే, డాక్టర్ దగ్గరికి వెళ్తేనే వాడు ప్యూర్ ఆక్సిజన్ పెడతారు మనకి. Until and unless we are inhaling the mixture of components, that means all are becoming impure. That's why whatever inhaling is impure oxygen. In the sense, oxygen along with some other components. మీకు ఆ పర్సంటేజ్ కూడా ఉంటుంది నైట్రోజన్కి ఆక్సిజన్కి. ఎంత పర్సంటేజ్ అది? 74-24 ఏదో పర్సంటేజ్ ఉంటుంది. కెమికల్ ప్రాసెస్ క్యాలిక్యులేషన్ చేస్తారు మీరు. So that means what? Your fractions are not pure. Some innards are coming into the system and they will come, they will go. Clear? Let's do one problem so that you'll come to know. Now let us look at, open the textbook, Levenspiel. Because I have given the assignment with last question as derivation part. For the variable volume derivation I have given. Open page number textbook 69. 69. Page number 69. Just look at page number 69. You are maybe in the left hand side. Your V is changing. Your V is changing. V is equal to V naught into 1 plus epsilon A XA. Equation 6.63a. Is it okay? 63a, is it okay? V into V naught in V is equal to V naught into 1 plus epsilon A XA. What is epsilon A there? What is epsilon A there? Fractional change in volume. What is XA there? What is XA there? Conversion. So from that equation, can you get conversion? That is next equation. XA is equal to V minus V naught by V naught into epsilon A. Just rearrangement. Are you getting or not? Is it clear? For variable volume case, your XA formula is V minus V naught by V naught into epsilon A. That will simply come from this equation. Just rearrangement from this equation. Get XA is equal to V minus V naught by V naught into epsilon A. Okay. And now check with equation number 65. 65. We know that equation. Na is equal to Na naught into 1 minus X. We know that. From that only, if we divide with V, we get Ca is equal to Ca naught into 1 minus Xa. If we divide with V, Na by V is Ca, Na naught by V naught is Ca naught. So we got Ca is equal to Ca naught into 1 minus Xa. We know this formula. But now we should not make V or V naught equal here. For constant volume case, V and V naught equal. That's why Na by V or Na naught by V naught, because V is V naught. We are getting 1 minus Ca is equal to Ca naught 1 minus Xa. But now here V changing. V becomes V naught into 1 plus epsilon Xa. That's why your next expression, you look at next expression. Ca is equal to Na by V. Ca is equal to Na by V. But here V is V naught into 1 plus epsilon Xa. So your Ca becomes Ca naught into 1 minus Xa by 1 plus epsilon Xa. So your 66 equation, Ca is equal to Ca naught into 1 minus Xa by 1 plus Xa. Epsilon Xa. See, already you know this formula. Ca is equal to Ca naught into 1 minus Xa. You know this formula for constant volume case. Ca is equal to Ca naught into 1 minus Xa. You know the formula for constant volume. Whenever variable volume comes into picture, just divide by 1 plus epsilon Xa. This term will come. Check the equation. That's all. This term will come from all the equations because this is the only term affecting the volume. Your volume is equal to initial volume, only this particular term. This will come into picture every time in all the equations. So equation number 66. Clear? Now just check page number 70. See page number 70 for zero order, first order, second order. Just remember for constant volume case how we derived. How we derived for zero order case for first order, because minus Ra is equal to minus dC by dt is equal to K into Ca power 0. Fine. We have started like that. Here also we do like that, but here our Ca or V changing. V changing. V is equal to V naught into 1 plus epsilon Xa, or Ca changing. Ca is equal to Ca naught into 1 minus Xa by 1 plus epsilon Xa. So your equation change for constant volume case to variable volume case. So wherever V comes into picture, replace V naught into 1 plus epsilon Xa and derive same thing. How we have proceeded for constant volume case, you just derive. So that is the derivation. And for zero order, look at equation Ca naught by epsilon A into ln V by V naught is equal to Kt. Remember for zero order, for constant volume case, Kt. So here because variable volume is comes into picture, your epsilon A comes into picture. So Ca naught by epsilon A ln V by V naught is equal to Kt. Now similarly for first order, look at the expression minus ln 1 minus delta V by epsilon A V naught equal to Kt. Delta V means V minus V naught. Change in the volume V minus V naught. V naught is initial, V is final. Remember the equation for first order constant volume case. So slight difference. Only thing is your volume is changing. That you should remember. And these are all simple expressions only. Does not take much time in derivation. Small expression, రెండు steps లో వస్తాయి ఇవి, ఎందుకన్నా పెద్దవి కాదు. Now for the second order, look at the second order expression, equation number 73. 1 plus epsilon A into delta V by V naught epsilon A minus delta V plus epsilon A ln of 1 minus delta V by V naught into epsilon A is equal to K into T. Okay. So three equations, only three equations for variable volume. You have to remember the equations. ఎగ్జామ్కి వెళ్ళే టైంకి నేను అక్కడ కూర్చొని డెరివేషన్ చేస్తానంటే పుణ్యకాలము షష్టి పూర్తి అన్నీ అయిపోతాయి. సో అలాంటి ప్రయత్నాలు జిమ్కి చేయకండి. వెంటనే ఫస్ట్ ఆర్డరు వేరియబుల్ వాల్యూమ్ అవగానే ఈ ఈక్వేషన్ మైండ్లోకి రావాలి. గుర్తుపెట్టుకోవాలి, వేరియబుల్ వాల్యూమా కాన్స్టెంట్ వాల్యూమా, మళ్ళీ ఆ ఈక్వేషన్ ఇక్కడ తీసుకొచ్చి పడేయకండి. That is constant volume. Now it is variable volume where your V is changing. Your epsilon A comes into picture. Okay, note on the problem. Find the first order reaction rate constant K. Find the first order reaction rate constant K of the gas reaction. K gives P of the gas reaction. 2A gives P. Two A gives P. By keeping the pressure constant. Find the first order reaction rate constant K of the gas reaction 2A gives rise P by keeping the pressure constant. Starting with 80 mole percent A and 20 mole percent inert. Starting with 80 mole percent A, 20 mole percent inert. The volume of the reaction mixture decreases by 20% in 3 minutes. The volume of the reaction mixture the volume of the reaction mixture decreases by 20% in 3 minutes. First order, already he has mentioned first order, but now he has already mentioned pressure is kept constant. Pressure kept constant means volume is varying, that is the only indication. So variable volume problem, whenever variable volume problem comes into picture, epsilon A should be comes into our mind, because epsilon A represents the fractional change in the volume, because your volume is changing. Now we need to calculate epsilon A. Epsilon A is equal to volume at 100% conversion minus volume at 0% conversion by volume at 0% conversion. Because inerts are given, we should be very careful. If no inerts are there, it's very easy to calculate epsilon A. But inerts are there, we should be very careful. So again, I am explaining. ఇందాక చెప్పిన మళ్ళీ ఒకటి చూడండి. ఎందుకంటే ఇన్నర్స్ ఇచ్చినప్పుడు ఎప్సిలాన్ కరెక్ట్ గా కట్టుకోవాలి. 100% completion. How many numbers of moles change? 0% completion. How many number of moles change? We will check calculate. Let us check with 100% conversion. 100% conversion means check out the reaction. Understand first. 2 moles of A becoming 1 mole. Look at here, 1. 2 moles becoming 1. That means it is becoming half when I given 100% time for conversion. Is it the meaning? Understand? 100% if I give, starting with 2 it will become half here. It will become 1. So I am starting with only 80% only for A. That means 0.8 into 1 by 2. It is becoming half. This is becoming half. 2 moles becoming 1. That means it is becoming half. That means what? How many moles? 0.4 moles for A. 0.4 moles for A. What about inerts? Inerts will not change. Inerts తగ్గిపోవడం పెరిగిపోవడం ఏం ఉండదు అది inerts. Now let us come to that side. 0% conversion. 0% conversion means as it is ఏమున్నాయో అవే ఉండిపోతాయి. As it is ఇక్కడ ఎంత వస్తాయో అంత ఉంటుంది. As it is పాయింట్ మూవ్స్ అలా ఉండిపోతుంది. That is called 0%. Nothing is converting. Inerts will be already there. Inerts model కదా 100% conversion inerts so 0% conversion inerts model. So this will be become 1 here. This will be how much also? -0. So your epsilon is equal to -0.4. Now you already know the expression. V is equal to V naught into 1 plus epsilon A xi. V is equal to V naught into 1 plus epsilon A xi. What he has told? He has told the volume decreases by that means let us say see I start let us think. I started with let us say V naught volume initially. Now my final volume will be initial గా let us say నేను 10 moles తో స్టార్ట్ చేశాను 10 moles తో ఫైనల్ వాల్యూమ్ ఎంత ఉండాలి 20% తగ్గిపోతున్నాడు అంటే 8 moles ఉంటుంది ఎందుకంటే 20% పోయింది అంటే 2 moles పోయింది ఫైనల్ గా మిగిలితే 8 అంటే if I start with initially V naught my final case will be 0.8 times of V naught because 20% decreased. Decrease అయిపోయింది సో ఫైనల్ గా ఎంత ఉంటుంది ఇనిషియల్ 80% ఉంటుంది ఎందుకంటే 20% డిక్రీజ్ అయిపోయిందంటే ఫైనల్ ఎంత ఉంటుంది 80% ఆఫ్ ఇనిషియల్ సో యువర్ ఫైనల్ P will be 0.8 times of V naught 0.8 times of initial so your final will be 0.8 times of V naught initial V naught is equal to 1 plus epsilon already minus 0.4 something into xl so calculate xl from this expression. You fine? Rate constant. So what is first order variable volume expression? Just to we have seen minus 1 minus close bracket equals to KP. Now let me in this expression delta V is what? V minus V naught means because at 3 minutes. So you know T, you know epsilon. Can't you get K? Calculate. Zero, 0 point. Correct. 0.31 means okay. So A, for the disappearance of A, for the gas phase reaction, for the gas phase reaction, A gives 1.6 R. For the gas phase reaction, A gives 1.6 R. If the volume of the reaction mixture mixture starting with pure A, starting with pure A, increases by 50% in 4 minutes. If the volume of the reaction mixture starting with pure A increases by 50% in 4 minutes. Full stop. The total pressure remains constant at 1.2 atmosphere. The total pressure of the system remains constant at 1.2 atmosphere and temperature 25 degrees centigrade. So asking for the first order rate constant. Fine. Given A gives 1.6 R. Told the total pressure remains constant. So pressure constant means variable volume. So calculate epsilon A. Then already mentioned is a first order. Do it. Is there any interrupt given? So Q told. So volume minus volume conversion. A gives rise to 1.6 star. So it comes to 1.6. Minus 0. How much it started with? 0. So 1.6 minus 1, 5. That will be extra unit. No other things already mentioned first order. 0.44. Correct. So how we will calculate the expression for first order? Minus ln 1 minus delta v by v naught epsilon a xa equal to k50. Here the final volume is, read the statement, volume increases by 50%. Volume increases by 50%. So what will be final volume? 1.5 V naught. Your V will become 1.5 V naught because it is increases by 50%. So your V will be 1.5 times V naught. Now you substitute. So delta V is equal to V minus V naught. That is 1.5 V naught minus V naught by V naught. Epsilon you know. T given. Zero point 447. Okay. You get 0.447. Next, note down. The first order homogeneous gas phase reaction. The first order homogeneous gas phase reaction. A gives rise 2.5 R. A gives rise 2.5 R is carried out A gives rise 2.5 R is carried out in an isothermal batch reactor. In an isothermal batch reactor at 2 atmospheric pressure. At 2 atmospheric pressure with 80 mole percent A. With 80 mole percent A and 20 mole percent inerts. With 80 mole percent A and 20 mole percent inerts, and the volume increases by 60% in 20 minutes. $80 mole percent A and 20 mole percent inerts, and the volume increases by 60% in 20 minutes. In case of a constant volume reactor, in case of a constant volume reactor, in case of a constant volume reactor, determine the time required for the pressure to rise to 8 atmosphere for the pressure to rise to 8 atmosphere if the initial pressure is 5 atmosphere. If the initial pressure is 5 atmosphere, 2 atmospheres of which consist of inerts. See, this is actually a problem connected with the two cases. In the first case, he has started with the variable volume case and he has given some data so that from the variable volume question you get some array of some formula or some notation, then use that information for the constant volume case, because the next problem it has come to be constant volume reactor case. So use the first information from the variable volume, determine something, keep it aside, then come to the second case where for the constant volume case what he is asking. Okay, we will go ahead. First read out the first lines. He has given A gives rise 2.5 R and it is in a variable volume case with 20 mole percent A and 20% inerts, 80% A and 20% inerts. Okay, fine. So now determine epsilon A first. Priyanka, can you go and find out epsilon A for this case? A gives rise 2.5 R. Let her go and do it. A gives rise 2.5 R. Epsilon A is equal to, write the formula, volume at 100% conversion, V at xa equal to 1 minus V at xa equal to 0 by V at xa equal to 0. Now what is the equation given? A gives rise 2.5 R. Just change first 2.5 R. And wait a minute. What is given? Pure fractions or inerts? Inerts. So whenever inerts are there, what you have to do? You have to make a table. 100% conversion, what are the moles change? 0% conversion, what are the moles change? What is the data given? 80% A, note down. 80 mole percent A, 20% inerts. Now you do it. If the 100%, what is the total number of moles? 100% conversion? Yes, 0% conversion. Now start with 100%. If A is 100% converted, what is the value? 2.5. What is A here? 80%. 0.8 times of 2.5 into 2.5. What is that value? 2. Now next one. No, there only, because inerts will be there. How many inerts? So 0.2 moles. 20% means 0.2 moles. 0.2 moles. Now this person, this time 0%. As it is 0.8. Inners 0.2. No. Why you are multiplying? 0% capacity means whatever yield is there will be as it is. Whatever yield is there will be as it is. 0.8. So whatever ignorance will be as it is. So what is the code? Add it. Here will be 1.1. Here 2 plus 0.2. So what is the answer? 2.2 minus the formula. 2.2 minus 1 by 1. 1.2. No, not minute inverse. You are not calculating anything. 1.2. Sure. Okay, next. After calculating epsilon A, what is next? Your volume increases by 60%. That means your final volume is equal to 1.6 times of V naught. Increases by 60%. Your final volume will be 1.6 times of V naught. Okay. So your expression minus ln 1 minus delta V, that means V minus V naught. Okay, from that, what is your K value? 0.0346 minute inverse. You keep the data aside. Now we have to go to the problem for the second case because he is asking to use this data for the constant volume case. Understood the first part of the problem? First part of the problem, using variable volume, calculate K. That K is you are getting as 0.0346 minute inverse. Now look at the problem for the constant volume case. That means pressure is varying. Fine. What is the total pressure given? Total pressure is given 8 atmosphere. That means capital P given 8. Fine. And initial pressure is 5. Initial pressure is 5. Okay. Fine. But what is the expression for partial pressure to total pressure? Partial pressure to total pressure. A by delta N P naught. So here, because why I am calculating PA here? Because if I know PA, I can calculate CA. If I know CA, from the expression for the first order constant volume case, minus ln CA by C naught is equal to K into T. From that I can calculate T because he is asking the time. Is it not? He is asking the time. Understood? So I am going back. Focus on here. Problem పక్క వింటే అర్థమవుతుంది. మీ వేలో ఆలోచించుకున్నారు అనుకోండి, you do mistakes. మనం ఏమనుకుంటాం అంటే అప్పుడప్పుడు we feel that we learn so many things. But the moment when I give any question in the examination, your hands up. Because your thought provoking will be always in a direction where I have learned all the things. You won't focus on what the teacher is saying. అర్థమైందా? ఏం అర్థమైంది నీకు? The first case where we ended up with calculation of K, we have to use the data for the second case. Second case, for the constant volume. Constant volume means pressure is varying. We need to calculate T. Fine. Now, whenever we are asked to calculate T, we have to go back to the case. What is the data given? Data given in terms of the pressures. So, whenever pressures are given, we should remember the pressure equation. Partial pressure is equal to PA to the total pressure. We have the equation. If I know PA expression, I can get CA because PA by RT is CA. If I know CA, I know expression for the first order constant volume case as minus ln CA by C naught is equal to K into T. So I can solve from that equation the T what is asked in the problem. So I have to get back so that I can use the pressure data. Now when I am using the pressure data, partial pressure is equal to PA naught minus A by delta N. You know everything. You know that total pressure P. You know initial pressure P naught. Fine. But what is PA naught here? What is PA naught? But we need to remove the inert pressure. Inert pressure is given as 2 atmospheres. So that PA naught will become 5 minus 2 because we have to remove the inert pressure. So now you can calculate PA from the expression because you know everything. What is A? A is 1. What is delta N? 2.5 minus 1 because delta N is equal to product stoichiometric coefficient minus reactant stoichiometric coefficient we have done. So 2.5 minus 1 is your delta N. You substitute everything there. P you know. What is P? P I think 8 given. P naught given. Total P naught 5 given. If you substitute everything, you will get partial pressure PA is equal to 1 atmosphere. అది ఫైనల్ ఇనిషియల్ ప్రెజర్ ఇది పార్షల్ ప్రెజర్ మాట్లాడుతున్నాం if your final initial pressure is equal to initial partial pressure if it is pure components, it's not pure components, inerts are there, so your A is not affecting with your inerts, but it has initially some pressure. Getting clear? So అక్కడ తీయకూడదు, అక్కడ P naught 5 ఉంటుంది, ఇక్కడ PA naught లో inerts ప్రెజర్స్ తీసేయాలి. Inerts are not giving anything. So your PA will become 1 atmosphere. Now you know expression for first order. Helen, what is first order equation? So you know PA now. So you can calculate T from that. So actually the problem consisting of the two things. It's a clubbed one. From the first data you have to use for the second data. Clear? So what is the time now? 31.7 minutes. Calculate small PA. Partial pressure of A 1 atmosphere వచ్చిందా చెక్ చేయండి ఫస్ట్. PA equal to 1 atmosphere వచ్చిందా? ఫస్ట్ ఆర్డర్ ఎక్స్ప్రెషన్ ఏంటి మరి? minus ln CA by C naught is equal to KT. Okay. So because CA is proportional to PA, CA naught is equal to PA naught. So what is PA naught? 3 atmospheres. Okay. Use the K value given. Yes, you note down this problem. You can solve a liquid phase second order reversible reaction. A liquid phase. What is the answer? Correct. Yeah, a liquid phase second order reversible reaction. Huh? PA not 5 తీసుకుంటాం. PA not 5 లోంచి 2 atmospheres తీసేసేయాలి. That is 3. అక్కడ P not ఇనీషియల్ ప్రెషర్. టీము ఇనీషియల్ ప్రెషర్ ఉంటుంది స్టార్ట్ అయినప్పుడు, కానీ ఏకి ప్రెషర్ క్రియేట్ చేయదు అది. మనం మాట్లాడుతుంది పిఏ నాట్ మాట్లాడుతున్నాము, నువ్వు పి నాట్ మాట్లాడుతున్నావు. పి నాట్ అనేది ఇనీషియల్ ప్రెషర్. ఏ దగ్గర ప్రెషర్ ఇనర్ట్స్ ఏకి ఏం క్రియేట్ చేయదు, కాబట్టి ఇనర్ట్ ప్రెషర్ తీసేయాలి. ఏ దగ్గర పిఏ నాట్ 5-2. గెటింగ్ క్లియర్? పిఏ నాట్ ఈస్ డిఫరెంట్, పి నాట్ ఈస్ డిఫరెంట్. పి నాట్ ఈస్ ఇనిషియల్ ప్రెషర్, PA naught is pressure for the component A, where for component A, inerts are not going to give any pressure. We should remove the pressure from component A. A liquid phase second order reversible reaction. A liquid phase second order reversible reaction. A liquid phase second order reversible reaction. A plus B gives rise R plus S. A liquid phase second order reversible reaction A plus B gives rise R plus S is carried out with the same molar concentration of A and B with the same molar concentration of A and B in the reaction mixture. With the same molar concentration of A and B in the reaction mixture, given Ca naught is equal to Cb naught is equal to 0.052 moles per liter. The equilibrium constant of the reaction is capital K is 1.45. 1.45. Given the following data, find the rate expression. Given the following data of time versus fraction of A converted, Find the rate expression. So this is the last variety of the problem from chapter number 3. So this ends chapter number 3 completely, so that from the next class I will start with the design of the reactors. What exactly you mean by the design, and how do we design the reactors, how we sequence the reactors for improving the conversions and selectivities or yields. This problem is direct problem. If you look at it, it is a second order reversible reaction because A plus B gives rise R plus N. A plus B gives rise R plus N. So every data is given. You know the expression because I already told. Reversible reactions, first order, what is the expression? Reversible reactions, second order, what is the expression? You know, the data is completely given. Okay.